Okay, so remember that the derivative, the directional derivative, in the direction of the unit vector u is equal to the gradient of f dotted with u. Okay, now use a unit vector, remember that. And another formula, or one formula for gradient of two vectors would be the magnitude of one of the vectors, of the first vector, times the magnitude of the second vector, times the cosine of the angle between them. Now here, u is a unit vector, so this is equal to 1. And this is just equal to the gradient of f times cosine theta. Wow. And remember, theta is the angle between u and the gradient of f. Okay, so now if we want to find the theta that maximizes this expression, then we want cosine theta to be equal to the biggest thing that it can be equal to. The biggest thing it can be is 1, and that means theta is equal to 0. So this is the biggest. So DUF is largest. Sorry about that phone ringing. When theta is equal to 0. That is, when u and the gradient of f are parallel. In other words, when u and f are multiples of each other. Okay, so the biggest the directional derivative is going to be is when the gradient of f and the direction that you're going in have the same direction. And that explains this. Why the gradient points in the same direction of maximum increase. Again, because the gradient or the directional derivative of f in any direction, that's what this is. This is another formula for it, the magnitude of the gradient of f times cosine theta. The biggest this can be is when theta is equal to 0. But remember, theta is just the angle between the direction vector u and f. And so if that angle is equal to 0, it means that u and the gradient of f have the same direction.